For most of human history, we were not alone. Right now, exactly one human species exists on this entire planet. Us, Homo sapiens. That feels normal, because it's all any of us has ever known. But for almost the entire story of human evolution, that was not the case at all. As recently as 40,000 years ago, at least 4 or 5 different human species were alive at the same time. Homo sapiens, Neanderthals in Europe and Western Asia, Denisovans somewhere across Asia, a tiny species nicknamed the Hobbit on the island of Flores in Indonesia, and possibly a few others we're still piecing together from fragments. Go back a bit further to around 300,000 years ago, and the picture gets even more crowded. Homo erectus was still hanging on in parts of Southeast Asia. Various other archaic human relatives were scattered across Africa and Eurasia. For most of our evolutionary history, sharing the planet with other human species wasn't the exception. It was completely normal. Then, over a relatively short window of time, every single one of them disappeared, except us. So the real question isn't just what happened to them. It's why we're still here to ask the question at all. Let's start with the species we know the most about, the Neanderthals. Neanderthals were not the dim-witted brutes they're often shown as. They had brains roughly the same size as ours, sometimes even slightly larger. They made sophisticated tools, controlled fire, buried their dead, and likely had some form of complex communication. They survived brutal Ice Age Europe for over 300,000 years, which is significantly longer than modern humans have existed so far. And here's a detail that surprises a lot of people. Neanderthals didn't fully disappear. If you have European or Asian ancestry, you likely carry a small percentage of Neanderthal DNA right now, inherited from interbreeding between our species tens of thousands of years ago. So in a strange way, Neanderthals didn't go extinct in the cleanest sense. They were absorbed partially into us. The same is true for the Denisovans, a species we barely have any fossils for, known mostly from a few bone fragments and teeth found in a Siberian cave. Yet genetic studies show some populations in Asia and Oceania today carry meaningful amounts of Denisovan DNA, including genes that may help certain populations handle high-altitude environments even now. So the honest starting point here is this. It wasn't a clean replacement. It was messier and more connected than the old story suggests. But the pure population numbers still collapse dramatically for every species except us. So what actually gave Homo sapiens the edge? Theory 1, and probably the most discussed, is cognitive flexibility. Somewhere between 100,000 and 50,000 years ago, the archaeological record shows a shift in what Homo sapiens were creating. Symbolic art, personal ornaments like beads and pigments, more complex specialized tools. This period is sometimes called the cognitive revolution, though researchers still debate exactly how sudden or gradual it really was. Sites across Africa, like Blombos Cave in South Africa, have produced engraved ochre pieces and shell beads dating back over 70,000 years, evidence that symbolic thinking was already well underway, even before the major migrations out of Africa that eventually spread Homo sapiens across the globe. What this points toward is a growing capacity for abstract thought and symbolic communication, possibly tied to more complex language. Language isn't just about talking. It allows planning across time, sharing detailed knowledge, and coordinating in ways that are much harder without it. Theory 2 is social network size. Some researchers argue that Homo sapiens groups maintained wider social connections than Neanderthal groups did. Evidence for this includes materials found far from their original source, like seashells discovered hundreds of kilometers inland, suggesting trade or exchange networks between distant groups. A wider social network means more than just trading objects. It means access to more mates, which helps avoid the genetic problems that come from small, isolated populations. It means access to more ideas, more innovations, and faster recovery after local disasters. since a connected group can receive support from neighbors rather than facing everything alone. Neanderthal populations, by contrast, appear to have lived in smaller, more isolated groups, based on genetic diversity studies of their remains. Smaller, more isolated populations are simply more fragile when conditions turn harsh. Theory 3 involves climate adaptability. The period when many of these other species disappeared overlapped with intense and rapidly shifting ice age climate swings. Homo sapiens, having originated in and adapted to a wide range of environments across Africa before spreading globally, may have carried a broader baseline flexibility for handling environmental change, compared to species that had specialized more narrowly for specific regions over hundreds of thousands of years. This doesn't mean Neanderthals were poorly adapted. They were extremely well adapted to cold climate hunting. But hyperspecialization can become a liability when the environment itself shifts faster than a species can evolve new adaptations. Theory 4 is more uncomfortable: direct competition. In regions where Homo sapiens and Neanderthals overlap geographically, some researchers argue Homo sapiens likely outcompeted Neanderthals for shared resources, like prime hunting grounds and shelter sites, similar to how two closely related species competing for the same ecological niche often results in one outcompeting the other over time. This wouldn't necessarily have looked like constant violent conflict. It could have simply meant Homo sapiens groups were slightly more efficient at extracting resources from the same landscape, leading to slow demographic decline on the Neanderthal side over many generations rather than any single dramatic event. Now, it's important to be honest about the limits of what we actually know here. Every one of these 4 theories has real supporting evidence, but none of them fully explains everything on its own. And researchers actively disagree about how much weight each factor deserves. The most likely honest answer is that it was a combination: cognitive flexibility, wider social networks, climate adaptability, and competitive pressure, all working together. Rather than any single dramatic cause, there's also the smaller, stranger cases worth mentioning briefly. Homo floresiensis, the so-called hobbit species, stood barely over a meter tall and lived in isolation on the island of Flores until surprisingly recently, possibly as late as 50,000 years ago. Their small size is thought to be an example of island dwarfism, where limited resources on an isolated island favor smaller body size over many generations. Their disappearance likely involves a mix of volcanic activity on the island and, eventually, the arrival of Homo sapiens into their previously isolated territory. And there may be even more human species we simply haven't discovered fossil evidence for yet. The story of human evolution keeps getting more complicated with every new find, not simpler. So why did only Homo sapiens survive? The honest answer is that we were more connected, more flexible, and possibly more adaptable across a wider range of environments and social situations than our relatives. Not necessarily smarter in some simple, single sense, but better positioned across several compounding advantages at exactly the moment the world was changing rapidly around all of us. And it's worth remembering, we didn't erase the others completely. Their genes are still here, quietly present in a huge percentage of living humans today. In a real sense, part of them survived after all, just not as a separate species anymore, as us. There's something oddly moving about that, once you sit with it. We tend to tell the story as one species winning and the others losing, but genetically it looks more like several ancient human lineages quietly merged into one surviving branch, carried forward without most of us ever knowing it. The next time you look in the mirror, remember, you might be carrying a small piece of a species that vanished 40,000 years ago, still quietly present in your own DNA. If you want to see what actually happened the day Homo sapiens and Neanderthals first met face to face, subscribe, because that encounter shaped everything that came after.